The next is micellae. The process of forming micellae is known as micellization. It is the process in which surfactants associate themselves to form a big associated colloid or micellae. At low concentration, the surfactant molecules stay as individual species, but at high concentration, they associate to form micellae. Typical micellae is spherical in structure, which contain 50 to 100 monomers. The number of monomers to form micellae is called aggregation number. This is micellization. Then the type of micellae, oil in water. That is, the hydrophobic head is pointing outwards and the hydrophobic tail inwards. Water in soil, amphibilic molecules can form micellae not only in water but also in nonpolar organic solvents. In such cases, micellae aggregates are called inverse micellae. That is, the tail, hydrocarbon tail is outwards and the head towards the inside. There is an aqueous phase and an oil phase. Next is critical micellae concentration. The lowest concentration at which micellae first appear is called critical micellae concentration. It is the point at which surfactant molecules aggregate together in the liquid to form micellae. Also, it is the concentration above surfactant when micellae will form spontaneously. Next is Kraft temperature. If the temperature is too high or too low, the micellization won't take place. That is, at a particular temperature only the micellization happens, and it is the temperature at which micellization takes place. That is, the temperature at which micellization takes place is called a Kraft temperature. All the properties of micellae remain within the definition that at a low concentration they stay as ionic entity or individual, but at high concentration they form micellae or associated colloid. Properties like conductivity, surface tension, entropy all revolve around the definition. Next one is conductivity. When an ionic surfactant dissolved in water or any other solvent, initially molecules or ions of surfactant move freely in the solution. When the concentration of the surfactant is increased, the conductivity will increase. There is the graph, that is the surfactant concentration versus conductivity graph is given. That is, initially the surface tension increases and after a particular concentration, that is designated as critical micellae concentration, ions or molecules start to associate to form micellae, that is micellization take place. Some free ions form micellae. Now the solution will have both free ions and micellae, but concentration of free ions decreases. Now if we plot the curve, the rate of conduction and the slope will be different from the curve that was obtained first. That is, the first curve is the conduction curve and no micellae is formed. The first curve is a straight line curve, that there is no micellae formation and it is only the conductivity curve. But here, when after critical micellae concentration, the conductivity has no change. That is, first curve is the conduction curve and no micellae are formed, and second curve is the curve when both micellae and free ions are present. From this plot, we can find the critical micellae concentration by measuring the difference in conductivity of the solution and the point where the graph change can be found. Next is molar conductivity. It is the conductivity per mole or it is the conductivity by 1 mole of the molecule. That is, during the starting period, when the solution is dilute, there is lot of free ions. These free ions help in the conductivity and value will be high. But as the concentration increases, more of the free ions start forming aggregates which result in the formation of micellae. At a particular concentration, there will be a decrease in the particular molar conductivity. This concentration is called a critical micellae concentration. And there will be a steep change in the graph. That is, in first the conductivity decreases, molar conductivity decreases. Then after the micellae formation, that is after micellization, conductivity curve will become steep. That is, a gradual decrease in the molar conductivity. the number of available free ions are getting decreased per mole as the ions combine to form the micelle. Hence the molar conductivity decreases with the decrease in concentration of the surfactant. Next is entropy of micellization. In the beginning, there is solvated surfactant molecule. Surfactant molecule has been solvated throughout by the solvent molecule. Once the micelle is formed, we have hydrophobic ion which is buried inside. That is, the hydrophobic part is inside, pointing inside, and the hydrophilic is towards the outside. And this forms a sphere. The solvent molecule attached with the nonpolar tail of surfactant monomer by hydration will be released during the self-organization. So, now the solvent molecule are only available on the surface of the sphere. There will also be a lot of unbound water available. These unbound water molecules are reason for the increase in entropy.